For years, Nvidia has ruled the AI inference stack. But Google just made a move that could change everything, quietly open-sourcing a tool called Raiden, built to challenge Nvidia at its own game.
All right, welcome to this explainer. Today, we're diving into a high-stakes, kind of invisible battle that's happening right now over the future of AI hardware infrastructure. For years, the conversation has been totally dominated by chips and raw compute, but there's a fundamental shift happening behind the scenes. We're going to focus on a major strategic move: Google open-sourcing its TPU Raiden library to directly compete with Nvidia's inference stack. This isn't just a simple software update, folks. It is a battle for the very foundation of how we build and scale modern artificial intelligence.
Here's how we're going to break it all down. First, the AI memory wall. Second, divide and conquer. Third, Nvidia's NIXL stack. Fourth, Google's TPU Raiden. Fifth, Raiden versus NIXL. And finally, the open source strategy.
Okay, part 1. The AI memory wall. The hidden bottleneck.
So, to understand why Google and Nvidia are battling over low-level code, we first need to look at the physical limits of modern generative AI. You'd probably think raw compute power or floating-point operations are the bottleneck, right? But actually, what really causes sluggish inference in large language models is a massive traffic jam in memory transfer. Generating text is autoregressive, meaning it spits out tokens sequentially, one by one, and doing that requires constantly shuffling insane amounts of data in and out of the hardware's high-bandwidth memory.
This active memory is what we call the KV cache, or key value cache. Think of the KV cache like trying to hold the entire wildly complex plot of a massive book in your head all at once, just so you can write the sequel, literally one single word at a time. The system has to retain the entire context of your conversation up to that point just to accurately predict the very next token.
And to put that into perspective, for just a 4K token sequence on a model like Llama 370B, you generate 1.3 gigabytes of KV cache. And all of that has to move instantly. When you're trying to transfer that massive weight of data across standard network sockets, that transfer alone can add real, noticeable milliseconds before you even get the first word of your output. When you're running millions of queries, yeah, that delay is simply unacceptable.
Moving on to part 2, divide and conquer, disaggregated inference.
The industry solution to this whole memory wall problem is an architectural shift known as disaggregated inference. Basically, it splits the workload into two completely distinct pools of hardware. This makes sure neither the compute-heavy prefill phase nor the memory-heavy decode phase gets bogged down. Instead of forcing one chip to juggle both jobs and do them poorly, you have a set of GPUs dedicated purely to crunching that initial prompt in parallel, and a totally separate set of GPUs whose only job is spitting out the answer token by token.
Now, the absolute critical moment here is step 3. That massive 1.3 gigabyte block of memory we just talked about, it literally has to physically travel over the network, from the prefill hardware over to the decode hardware, before a single word can be generated. That point-to-point transfer is the exact moment where the software transport layer will either make or completely break your entire system's efficiency.
Which brings us to part 3, Nvidia's NIXL stack, the inference transfer lib.
Enter the reigning heavyweight champion of this data transfer problem. We're talking about Nvidia's NIXL library. NIXL, which stands for NVIDIA Inference Transfer Library, handles these transfers at absolute wire speed. It utilizes this really clever decoupled architecture that dynamically registers memory to move those KV blocks across mixed cloud networks by totally separating the control plane, the conductor, from the data plane, the agent. NIXL lets AI frameworks route massive memory blocks over ultra-fast network protocols like RDMA or InfiniBand, or even straight to storage drives, without bogging down the main CPU. It is essentially the silent engine powering many of the largest AI deployments today.
All right, part 4, Google's TPU Raiden, the new challenger.
But now, a serious challenger emerges. Google has officially open-sourced TPU Raiden to bring bare metal memory routing directly to their cloud TPUs. This is a huge deal because Raiden bypasses Python's global interpreter lock entirely. By isolating its memory routing to native C++ background thread pools, it hits a jaw-dropping 200 gigabytes per second of bidirectional bandwidth over PCIe. Plus, through zero-copy memory aliasing, it tricks the hardware into moving data between host memory and TPU without wasting time on bounce allocations. But honestly, my favorite feature? The warm boot crash persistence.
It uses your server's shared memory, so if your inference container crashes or restarts, your massive KV cache survives right there in the host RAM. That completely prevents those agonizingly slow cold starts.
On top of that, when TPU memory fills up, say during super long conversations or with deep reasoning models, Raiden automatically streams those inactive KV blocks over to cheaper host CPU RAM. It acts as a massive, ultra-fast Tier 2 cache. Then, when those context blocks are needed again, it just pulls them right back into the TPU, which drastically cuts down on expensive recomputation. It's an incredibly elegant way to squeeze every single drop of value out of the hardware.
Let's look at Part 5, Raiden versus NIXL, 2 paths to peak. So, going head-to-head here, we aren't really declaring an absolute winner. Rather, it's about seeing 2 completely different engineering philosophies tackling the exact same memory wall. Nvidia engineered NIXL to be highly flexible across mixed cloud environments using that decoupled control and data plane. Google, on the other hand, engineered Raiden to fit like an absolute glove within its own highly optimized physical TPU slice topologies, leaning on their pathways runtime to scale. Google's tight integration with its JAX compiler and local shared memory versus Nvidia's flexible multi-tenant memory registration over RDMA, they are simply 2 different paths to peak efficiency. Both are absolute masterclasses in systems engineering.
Finally, Part 6, the open source strategy, breaking hardware lock-in. So why does all this deeply technical software matter to you, the developer or the business leader? Well, it's all about breaking hardware lock-in. For years, Nvidia's real moat hasn't just been their silicon, it's been the software stack that makes deploying models so easy. By open sourcing Raiden, Google is effectively building a bridge right over that moat. They're making their TPUs just as developer-friendly for complex disaggregated inference as Nvidia's GPUs. This strategic move means that enterprises scaling massive generative AI models no longer have to rely exclusively on a single chip vendor.
And the market is absolutely shifting because of it. Heavyweights like Anthropic and OpenAI are already securing massive TPU capacity. Because high-level serving frameworks like VLLM and SGLang now support both NIXL and Raiden underneath the hood, developers can seamlessly bounce their workloads back and forth between GPUs and TPUs. You don't have to write custom transport code for different chips anymore. You can literally just route your inference to whichever hardware gives you the absolute cheapest cost per token at that exact moment. It forces co-opetition in the market, which is a massive, massive win for users.
So, I leave you with this final thought to ponder. As these software walls keep coming down and complex memory orchestration becomes totally open-sourced, who will ultimately win the battle for the modern AI data center? Will it be the hardware makers or the framework developers who abstract them away entirely? Thank you for joining me on this explainer. Keep your eyes on the transport layer, folks, because that is where the real wars are being fought right now.
By open-sourcing Raiden, Google is reducing the friction to adopt its hardware, giving every developer a potential alternative to the Nvidia ecosystem. The question isn't just about hardware anymore, it's about accessibility. Is this the start of a TPU revolution? Tell us your thoughts below.